yeah, just before the beginning, I just want to say thank you to all of you guys for driving like hours to this place, attended this meeting all together. It's like precious to have you guys. So we're gonna do some introduction about Pytes low voltage and high voltage solutions to help you guys know more about our company and also our products. So we can get started from here. So Pytes, we started from the year of 2004, and at that time I was only a primary school student, so like long time ago, more than 20 years. Yeah, so we have over 1,000 employees spread over 6 continents, and we have employees working in different countries as well, like over 60 countries. So right here, Logan and me and Echo, maybe you guys gonna see her later. She's a CEO for Pytes UIC team. So we support each other to help you guys, to help our distributors or installer and end users. And we also have team in Europe and South Africa, and also South Asia, and Australia, lots of places. So Pytes is a worldwide company. And here, as you can see, oh yes, and Pytes has over 20 years of battery manufacturing experiences, yeah, for quite a long time. And here, if you look at the picture, this is our headquarters, Shanghai. Yeah, and here, these are the 2 manufacturing facilities in Shandong. We manufacture cylindrical cells as well. So it's like mini size 18650. And here we have the production line in Vietnam as well. Yeah, so that's us. So Pytes is a big company, and we have different divisions as well. So not only energy storage, we also have LEV, we call it light electrical vehicle, and we make battery packs for e-bike, e-scooter. And like I mentioned, we also make the cylindrical cells, like mini cells, for personal care stuff, like shaver or electrical toothbrush. Yeah, so maybe some of you guys are using Pytes battery when you're brushing your teeth, or yeah. Yeah, so yeah, very important. This is our energy storage department, and we provide solutions for residential and commercial and industries. And starting from left, we have our V5. This is our bread and butter. So you guys gonna see the V5 right behind you guys when we do the hands-on installation. We're gonna play with it. So we have also, like on the top is a container, like the cabinet for the matching with the battery. This is an outdoor cabinet, can have 4 pieces of V5 put inside. And we also have different solutions, like rack style and also like indoor, like V-Box IC. So we have different solutions to make you guys flexible. So you can choose your, based on your preferences. And this one is V10, right here, I think. This is V10. Yeah, right here with a solar inverter. Yep, so this is our V10. And this one, you don't need a cabinet with it. So it's like battery is IP65. It's like free to go. And this one is a high low voltage stackable. It is pretty slim, and also it's cableless. So you don't need to connect cables all together, you know, it's like worry-free. And this is our high voltage solution. You can start from the 5 and max it up, and working with inverter, solar inverter 30K and also 60K. Yeah, those are just customers we wanna introduce to you guys. Probably Flyco. Maybe you guys see Flyco in Costco or some places. Yeah, we supply them the cylindrical cells, the mini cells. And also one of our favorite LEV customers is called Right Power Bike. So we supply 99% of the batteries, the cells for them. Yeah, so that's Pytes. But today we're going to talk more about energy storage. So here, this page, I want to spend more time to discuss our quality and performance. So Pytes is the real manufacturer and the direct manufacturer. That means we have the full control of our supply chain. So that really help us, reduce the dependency on the external suppliers or, other people, because we have our own facility and we manufacture for ourselves. And for example, during the tariffs time, yeah, during the tariffs time, it's around April to May, right? Especially, in face of tariffs uncertainty, we actually send out like over 20, 30 containers to North American market. We just want to secure, everybody, make sure you guys are in stock and we are not changing the price. So that's why during that period of time, we have no price change. So that's us. And also this way can help us maintain the very healthy ecosystem. So manufacturer, distributor, installers, and end users. So that's us. Real manufacturer. And for the cells, so there is no always best cells. There's no compromise on battery cells selection because, for example, I just mentioned about this company. Pytes has been in the industry for over 20 years, and our decision makers, our leaders, has been in this market for a long time. So they have a lot of experiences or knowledge about who are the best sales companies, and so that's why we can help us make the decision on choose the best cell company, best technology, and safest cell, and we can create battery packs and make batteries for you guys. So safe is very important for us, always the best components, and all UL 95 or all UL listed. And there's another highlight I want to talk about is our self-designed BMS. So Pytes actually do self-designed BMS. This is a very important feature because if you have the ownership of the BMS, then you can continue collecting data year by year, analyze it, diagnose it, and debugging it and make it better and better every single year. So like after 10 years, 5 years, 10 years, we get a better version of the products. So the next generation is always the better one. So that's why we have so many, variety of low voltage or high voltage product solutions. So Logan will introduce later and talk more about on it. And and here is quality control. So what I want to share my personal experience is when I was visiting our production line, the manufacturing line, we have a designated room, a special room. We do the testing. It's called aging test. So we put the batteries in that room and do the charging and discharging for 48 hours before we send out the batteries, put it in the box and give it to you guys. So actually this step is very important to filter the weak cells or the problem batteries and make sure we are giving you the best one. So that's why when you are using Pytes battery, there's a very low defective rate. So that's why we have the number here. Our failure rate is actually lower than 0.3%. And based on the recent data, this actually means 3 out of 1,000. And recently we got the data is 0.18, so which means 1 or 2 out of 1,000. So we choose the best components and the best cells. That's why, so we can keep, save your time on after sales because we don't want you guys travel so far away, like 5 hours driving, 4 hours driving, back and forth. So we want to make sure you guys are easy on your job. All right, so I guess we can switch. So Michael or Logan gonna introduce more about the low voltage solution and high voltage solution, more about our products. So enjoy. Yeah.
All right, thank you, August, for the intro. And I just want to say thanks again, everybody, for making the trip out, especially those of you who drove 5 hours from other states. It means a lot to us for you guys to be here. Shout out to NAZ as well for hosting. They've been a distributor of ours for a number of years now, one of the earliest adopters of Pytes, I think, in the US. And yeah, it's just been great to see the relationship grow over the past few years. And then thanks to Jock and Lauren from Solarc for joining us as well and all the kind words. Just to kick it off again, my name's Logan. I'm product manager with Pytes. What I do day to day is trainings like this. I do a lot of after sales support, help with product development, installer feedback type stuff. So we'll kind of start in the low voltage section. I'll introduce all of our residential solutions first. And then to kick that off, I'll show kind of our founding ESS product, and this is our eBox 48100R battery. This is a product that NAZ originally started carrying a few years ago. They do still offer it now. This is a battery that's been on the market for 7 or 8 years now, I think. It's basically at end of life at this point, but just kind of wanted to show this. This is how it all started for us in the world of energy storage systems. So Server rack style form factor, it's a 5 kilowatt hour, 100 amp hour battery, 51.2 volts nominal. And then, yeah, backed by our standard 10-year warranty, 6,000 cycles at 90% DOD. This battery, like I said, has been out for a while. And I think nowadays, really the only time I would recommend this is if somebody is very strapped for budget, or if they have these batteries already in an existing system and they're wanting to expand and make their system a little larger. A little bit later on, I'll kind of show some more details as to why I would recommend a better battery like the V5 over the E-Box going forward from here on out. So one of the things I know, August, you mentioned, and it's I think a really important concept for us is innovation over time, right? So because we've been around for so long, we've got over 2 decades in the battery space, developing energy storage, developing BMS. Every new product we come out with is a little bit better than the last one. That's largely in part to people like you all, our installers, our distributors, people in the field that are actually working on the batteries, putting them together. It's you guys who are letting us know what's working well, what's not working, and that installer feedback we get from our customers is huge in helping us not just stay relevant in this industry that's always evolving, but to make our products better every single step of the way. So this is our V5 battery. It looks really similar to the E-Box. It's kind of the same concept, right? It's a server rack battery, 5 kilowatt hours. It has, in terms of improvements from that first version, it's got a 75 amp charge rate off of 100 amp hour capacity, so 0.75 C charge and discharge continuous. I think that's around 3.8 kilowatts in and out. It has integrated heating as well. The previous version did not have that, so that allows us to do installs in cold weather climates, do cold weather charging. And then we've also added another feature on this battery, which I'll talk a little bit more about later, but it's a port dedicated for our Wi-Fi dongle accessory. And I know Jock was mentioning maybe some of the differences or advantages even in having both Solarc's monitoring and our monitoring, using them together to kind of support one another. So for V5, the battery itself is indoor rated. It's like IP20, IP22. So if you need to install it outdoors, you're going to be using our OC cabinet that's got a 4 battery capacity, 20 kilowatt hours. This one for me is a really good option, even if you're doing it inside, because it's very plug and play. So this cabinet comes with everything that you need, except the batteries, of course, but everything that you need to connect the batteries together and then land them on the bus bar that's in this top section of the cabinet. So you can see your knockouts on the front. There's a little spot for the Wi-Fi dongle. The back side has a circuit breaker. But this cabinet ships in 2 pieces. The assembly is super, super easy and fast. And then, like I said, plug and play, basically everything is included. All of the other options up here are indoor rated options. Starting on the left, we've got our V5 brackets. That's kind of what you see right here. And I believe the batteries in the back have those brackets as well, so we can take a look at those later. You can do up to 6 batteries high with those brackets, so 30 kilowatt hours per stack before you've got to make a new group. By far the most cost-effective, easiest way to mount the batteries, to get them off the ground, to make sure we've got proper clearance between all of our units. So really, really cost-effective option. Obviously, right, you can see nothing is covered up. All our terminals and switches are exposed, so you don't want it in a high traffic area or anything like that. Then the 2 indoor cabinets, we're gonna have you all put one of these together today. I don't know if NAZ offers both, but they're basically the same thing, right? One comes with the walls and the door sides, one's just an open rack unit. These are neat because you can stack 2, and I've even had people stack up to 3 of these indoor cabinets on top of each other, so you can do 9 what is that, 45 kilowatt hours vertically. But indoor only, and if you've got the batteries somewhere that they can get bumped or touched on accident, it's kind of nice to have everything enclosed in that cabinet, and they're super easy to put together as well, which we'll see a bit later. So yeah, just some of the examples that we've got in the field. Solarc by far is our biggest inverter partner in the US, and we've got, hundreds if not thousands of installations, thousands of Pytes batteries in the field operating with Solarc inverters. So these are examples of those brackets. And you can see for a really big system like this, I think this might be 200 to 300 kilowatt hours.
270.
Yeah. You're better at mental math than me. Right, if you got more than 6, you just make a new stack and a new stack until you get what you need. Got a couple examples of the outdoor cabinet. The spacing between neighboring cabinets can be really short. I think it's like 1 to 2 inches. You don't necessarily have to have this installed under an eave or patio or roof or something, but yeah, I've seen it that way too. I've seen it done both ways. I'm always kind of a fan, the more protection you can give it, the better, right?
Absolutely.
But so yeah, that's kind of what they look like installed in the field. This is in Arizona. They've got multiple indoor cabinets stacked one on top of each other. Those cabinets too, I forgot to mention, they've got wheels at the bottom, casters. So if you've got to move it away from the wall to get behind it, or it needs to be mobile in some way, that's kind of our solution for that. So that's V5. I would say right now V5, or maybe better said, up to now, V5 is for sure our most popular product in the US and Canada, without a doubt. Moving on to another solution we offer. This is our Pytes LV1 stackable battery. So that's this one right here. And this product for me is really targeted for, I'd say, small to medium scale residential systems, and then just ease of installation overall. It's very simple to put together. There's no cables or busing you have to mess with. They just stack one on top of the other. You can do up to 6 batteries high. The modules in this case are the same as V5. They're 5 kilowatt hour, 51.2 volt nominal battery modules. They're all connected in parallel, so it's still a low voltage solution. What's a little different about the Pytes LV1 compared to the other low voltage products we offer is it's kind of comprised of 2 main pieces. So you've got your battery modules, which are just the batteries, right? They hold and discharge energy. But you've also got this other piece on top, which we call the BCU, or the battery control unit. So each of the modules has its own BMS built in. The BCU, you can think of that as like the brain of the system. So it's got a master BMS that's looking at all the modules. That's got your wiring compartment. That's where you connect your inverter cables. That's where you set your dip switches, your comms. It also has a circuit breaker on it, which is a nice feature as well. But you need the BCU in order to make the batteries work, right? So you always have to have both pieces. Minimum, you can do 2 in a stack, and like I said, maximum is 6. And I think now we can do up to 8 groups of 6, I believe, in total. So it's not quite as scalable as the V5, and I should have mentioned V5, you can do up to 96 of those batteries in a common system, which is just shy of 500 kilowatt hours. So, I mean, that'll cover pretty much any resi project I've ever worked on, and even getting into the small commercial stuff as well. So a couple other things to point out about Pytes. Again, the goal of this product was ease of installation and speed, right? That said, it does not have heating. So even though it is an outdoor rated battery, there's no internal heating. I know for some parts in the Southwest, that's probably fine. Probably not up here in the winter. You couldn't have this outside. So that's something to keep in mind. We're moving a lot of these right now in Puerto Rico at the moment because they don't need heating there, so it works perfectly. The other thing to keep in mind about this product, and actually we're working on upgrading this, but if you'll notice my little chart down here, right, you go from 2 to 3 to 4 all the way to 6 modules. With every battery you're adding to that stack, you're gaining more energy, more kilowatt hours, more amp hour capacity, right? But notice what happens to our power output, right? With each battery, you expect the power output from the stack to increase a little bit, which it does until you hit 4 batteries. And once we go from 4 to 5 to 6, your amp hour and energy capacity is still increasing, but your power output is capped. The reason for that is because these are outdoor rated, they're fully sealed, they don't dissipate heat as well as the V5, for example. So that's one of the reasons why we've limited the power output at about 10 kilowatts. The modules can for sure produce more than that, but that's kind of a safe value we found that prevents them from overheating, if you will. So what I'm getting at here is if you're doing a system, for example, with a Solar 15K, right, that can do, 12 kilowatts of AC output off the batteries and off-grid. So if you need 30 kilowatt hours for your Solar 15K, you need 6 modules no matter what, but you can't really put all 6 in one stack, right? Because at 6 together with 1 BCU, you've only got 10 kilowatts, which isn't going to satisfy what that solar converter wants. So the solution there is you just break those 6 modules into 2 stacks, and now you've got, 7.7 times 2, just about, or just over, I should say, 15 kilowatts total. So that's kind of how you, like I say, unlock additional power output with this solution, is you just make another stack. Some install pictures for Pytes V1. I think most of these are Puerto Rico, like I was saying earlier, but yeah, really, really clean, really, really simple, especially if it's like 1 stack to 1 inverter, or 2 stacks to a 15K, because it's got the 2 battery inputs. You don't need a bus or a combiner in between or anything. So those 3 products so far have been out in the market for a while. The next thing I'll introduce is going to be our V10 battery. I like kicking it off with that because it shows all the main highlights. But this is a brand new product from Pytes. This just was released within the past few months. We've got one on the wall here. I know NAZ was testing it. But honestly, something we're really, really excited about. The way I kind of explain this one is those 2 batteries we just looked at, V5, Pytes V1. Think of the best features from both of those products combined into one, plus a bunch of other stuff that we added. Going back to that concept of innovation over time, every single thing we make is a little bit better than the last. So this is no exception. V10, it's a 10 kilowatt hour battery. So it's basically the capacity of 2 of the V5s, yeah. Just right around 200 amp hours. And then this one is outdoor rated, IP66. It's got a high degree of corrosion protection. We've given you the option as an extra 2 years of warranty coverage, so 12 years total warranty, significantly higher energy throughput, and then a whole bunch of safety features, fire suppression, pre-charge circuit, things like that. I'll get to those in a second. But just a couple basic specs on the V10. Like I said, it's 10 kilowatt hours or just shy of that 10 kilowatt hours. Half C charge rate at 100 amps, discharge rate is a little higher than that at 120. And the peak discharge, it can hit about 10 kilowatts for, 3 minutes for surge. This one we can scale up to, I believe it is 16 units without our hub accessory. So you can do 160 kilowatt hours, which is, again, pretty much going to cover any resi size project I've ever done. The max scalability, I meant to confirm this earlier. We haven't done testing yet with our hub accessory, which is basically just a communications manager, because we think that, again, this 160 kilowatt hours is going to be sufficient for
99%.
the resi project this was designed for, right? If If you're doing something bigger than this, residential with low voltage batteries, the V5 is probably going to be a better option for a few different reasons. I just think, especially in some of those photos we saw, right, the way you can get many batteries in sort of a small space with V5 is one of its big selling points. But I'm expecting this to be a really strong product for us going forward as well. So what's behind the upgrade here, or one of the core elements, is a larger cell capacity. So all of our other low voltage solutions until now have been employing 100 amp hour 3.2 volt lithium iron phosphate cells, prismatic cells. V10, we've increased that to a 230 amp hour cell. Now it's a 230 amp hour cell, but we've rated that battery at about 200 amp hours, mostly to extend the life of that battery as much as possible, increase that total energy throughput as high as we can. That said, the cells, generally speaking, in addition to that capacity limitation, you're going to get a much higher, or I should say much longer lifespan with this compared to V5, compared to Pi, compared to e-Box. You've got 8,000 cycles, which is up from 6,000 cycles, and at the same 90% depth of discharge. I personally don't really like to talk too much about cycles, because I think if you talk to different battery manufacturers or whoever, the definition of a cycle isn't always consistent, right? I've heard it be like it's a full charge and a full discharge, or it's just a full charge, or it's a full discharge. So energy throughput for me is a much more true way of gauging that battery's potential, we can say. Total energy throughput is essentially the total amount of energy you can put into and take out of that battery throughout its entire life, right? We're getting rid of cycles, we're getting rid of time. It's like, here's the battery, this is what you can do with it, and that's what we're, backing it. And of course, that's down to a certain capacity retention and all that. But what I'm getting at with throughput here, we've doubled the capacity of the battery from 5 kilowatt hours to 10 kilowatt hours, but we've actually tripled the energy throughput compared to the V5 from about 20 megawatt hours, and now we've got close to 60 megawatt hours throughput with the V10. So again, really just trying to extend the battery life as much as we can. Higher capacity cells, they're also a little more efficient, lower resistance compared to the 100 amp hour cells, and they're more cost effective. So when we look at this V10 solution compared to what I introduced already, right? Compared to Pytes V1, for example, a 10 kilowatt hour stack, that's 2 modules plus your BCU against, right, one V10, which is already 10 kilowatt hours. That was about, and I was doing this based on NAZ retail pricing, that was about 35% lower than the cost of the Pi. Comparing that against V5 with the outdoor cabinet, it was about 25% lower, right? Because that outdoor cabinet's 4 battery capacity. With only 2 batteries, that's your 10 kilowatt hours. So you're maybe buying a little bit more cabinet than you need, but that's the only option we have right now for outdoor rated V5 installs. If we're looking at an indoor install, it's still really close. It was only about 5% higher compared to the V5 with the indoor brackets. So whether it's inside or outside, V10 is going to be a great option. But yeah, especially outdoors for several reasons. But quick shot of our packing list in the battery. You get the battery, obviously. You get a couple cover pieces. I'll point some of this stuff out later when we do the hands-on section. But power cables, 1/0, 2 meter positive and negative cables, comms cable, the wall mount bracket, all that stuff is included with the battery. We have another new product, and this is our V16. This is a 16 kilowatt hour battery, and it's using even higher capacity cells than the V10, 314 amp hour cells. Every single feature, safety, product-wise, that I introduced about V10, we have that all in the V16 as well. So I'm not really going to spend a lot of time on this, but we've got one on the wall. We'll check it out later. I just want to let you guys know this is what's coming. I think our UL certifications are going to be finished beginning of December. But for me, this this is something we're all really, really excited about at Pytes. These 314 amp hour cells, by the way, are essentially the same capacity cells they use in utility scale projects. So they're very, very widely available. They're super, super cost effective. Those price comparison examples I gave with V10, they're going to be even better with V16, given the higher amp hour capacity. But yeah, a lot of everything is essentially the same. It's just a larger battery, 16 kilowatt hours, as opposed to the 10. And I guess for me, when I first studied these two new products, my biggest question is, when do you use these, right? Because we've introduced now 4, 5 different low voltage solutions. So for me, any outdoor installation, look at V10 or V16, especially if it's coastal, especially if it's humid, cold climates to an extent, right? We kind of talked about some of the temperature limitations. So if you're, I don't know, doing a project in northern Canada, right, you can't just stick this on the wall and expect the little heaters to keep up, right? You're going to have to do something extra to make sure the battery stays at the right temp. If somebody's looking for a single battery install and a single inverter install, but they want a very high power output from that one battery, these are good options as well. This one for me is a bit interesting. I think if somebody's not planning for future expansion, both V10 and V16 are great choices. Now, I don't mean you can't expand an existing install, but when you look at something like the Pi, when you look at something like the V5 with those racks, it's much more plug and play to build onto those other solutions than it is to this. Because if you're adding another battery here, right, we're having to find not just wall space, but find out, you know, where's the studs on the wall that we can land a second battery. You've got clearances that you have to consider between the batteries on the sides and above. Not to mention, right, how are we routing the cables from the battery up to the inverter? Do we have space for more conduit? So just a lot more to consider, but that doesn't mean you can't expand it. I just think our other products are more easy to expand. If somebody wants a wall mount solution, I would definitely look at these. We don't really have a great wall mount option for V5. And yeah, long lifespan if that's a priority for your end user, which I would imagine it is for most people. Both of these products are going to be the best option as well. And that warranty, once again, it's 10-year standard warranty, and we offer an extra 2 years of coverage for purchase. So this theme of evolution over time as a direct result of installer feedback, I think this really illustrates that quite well. We started our journey in ESS with that E-Box battery 2017, right? It's been a super, super solid product for us. It's still being used today. We've still got batteries that were installed in 2017 that are working fine without any problems, but you can see, right, going from E-Box to V5, the improvements we made between those two models, which I kind of covered earlier. And right, that's over a 6-year time span. So that E-Box was our bread and butter, if you will, for a long time. V5 to V10, it's no different, right? We've kept everything that was good about E-Box. We've kept everything that was good about V5. We've put that all into V10, and we've made it even better. Higher capacity, higher charge discharge, the heating pad, all the safety features we talked about, the outdoor rating, the corrosion resistance. So again, just I think really proves the point that we try to get better with every new product we release. And I think it's kind of interesting to note, right? Look at the timeline now between V5 and V10. That's only 2 years as opposed to 6 before. Last thing on low voltage, and then we'll switch gears for a little bit. So one of the other improvements we've made from E-Box to V5 was how we build the cell packs that are inside the batteries. So on the left, you've got, well, we've got 2 batteries opened up. This is an E-Box, this is a V5. They're both those server rack style batteries. If you open those batteries up, you're gonna see 2, I call them internal packs. Each one of these is 24 volts with 8 cells in series, and then the 2 packs are series connected to make 48 volts, right? So what we're showing here are one of these cell packs opened up so we can see the individual cells inside and some of the internal wiring. It's a pretty big difference visually, right? Like this on the right, I think obviously looks a lot better, a lot more streamlined, a lot more high tech than what we have on the left. So E-Box batteries employed a traditional copper wire harness method. It's kind of hard to see in the picture, but you can see like each individual cell has a little tiny cable sending voltage and temperature info to a circuit board here. And then we've got a ribbon cable that connects to this board to our BMS. So it's kind of like what the BMS uses to monitor the individual cell data. And yeah, it looks kind of old school. It's a bit clunky, right? So V5, we've gone away from this wire harness system and we've converted that over to a more sophisticated, flexible printed circuit board. So it does the same thing. It's still monitoring the info or the data from all of our individual cells and reporting it to the BMS. But it's a lot more efficient and it's a lot less susceptible to failure, okay? So imagine you've got, 8, probably 10, 12 different connections on this board for voltage and temperature monitoring. These are all kind of like individually soldered on. I've seen some instances where one of the cables pops loose or the connection fails and now you've got one cell in your battery that's reading some crazy voltage or current or temperature that doesn't make sense. V5 doesn't really have that problem. It's just a lot more durable. It takes up less volume. It doesn't weigh as much and really just makes it overall more of a reliable product. All of our low voltage products as well have this flexible printed circuit board design in the cell pack. So it was really just that first E-Box release where we were using the wire harness method. But again, yeah, better over time with each step of the way, right? So the difference, as you would expect, is how are we connecting the modules, right? So all the Resi stuff I just went through, everything's connected in parallel, right? Positive to positive, negative to negative. We're increasing the amp hour capacity of the bank, but we're not changing the voltage, right? Parallel, our voltage remains the same, our amp hours go up. Series connection is the opposite. Series connection, we're doing positive to negative. We're not increasing the amp hours, but we are increasing the voltage. In the case of our indoor rated high voltage battery solution, which is this guy here, the modules are actually nearly identical to our V5. So if you see in these two photos, right, this is low voltage on top, this is high voltage on the bottom. The batteries look almost identical, yeah? They're 5 kilowatt hour modules, they're 51.2 volts. All we're changing is how we're connecting those modules. Now, I want to be clear, you cannot connect V5 batteries in series and you cannot connect the high voltage batteries in parallel. So they're two different models, but inside the bones, I guess, or the core of the batteries are the same. So what I'm getting at here is if you have a 6 battery system, whether it's low voltage and they're all in parallel, or it's high voltage and they're all in series, if you've got 6 batteries either way, your energy is the same in both cases, right? All that's changing is our amp hours and our volts, but it's still 30 kilowatt hours, 5 kilowatt hours times 6, no matter what. The reason I would like to kick it off with this is because there's a lot of benefits with high voltage batteries. And just to be clear, right, we're not unlocking some magical hidden energy that is just appearing out of nowhere, right? So it's important to note, right, energy is always energy, but you can change your volts and amps and still get the same result, right? Piggybacking off of that a little bit, I'll say pros and cons between the two options, right? Low voltage, right, most widely accepted solution for sure. Super common for any residential application. The accessories for low voltage systems are way easier to source than high voltage. They're readily available. It's a lot more DIY friendly, simple retrofit for existing systems, and more cost effective for smaller systems too, right? If you've got a small 48 volt inverter that needs a battery, you technically could use just a single battery and you have a complete functioning system, right? High voltage is a little different because we need at least 5 modules in series to satisfy the requirements for our control unit. But high voltage, for advantages, you've got lower losses, right? The potential's higher, so less voltage drop, smaller cable. I think it's a lot more cost effective for larger systems. And then the way we've designed our high voltage solution is you, at the end of the day, have fewer components and accessories than you would with the low voltage side. And then, yeah, 5 kilowatt hour modules, like I said, warranty is very similar. This is an indoor only solution. This was our first generation high voltage battery. So there's no heating pad. There's no fire suppression or anything like that. It's fairly basic, but the other thing to point out is similar to our stackable battery. Remember, we had kind of two components, the modules and the BCU. High voltage is exactly the same. So you've got your battery modules, which are super basic, scaled down server rack style. They all connect in series, and then they land on your BCU, which again is the master BMS. Actually, there is a contactor BMS in the BCU. Each module has its own BMS. But as you can see here, right, this is your user interface. This is where we're turning it off and on, your inverter cables, your comms, your communication protocol, dip switches, and everything like that. So for the indoor high voltage batteries, it kind of comes in 3 different options. Really the only difference is the cabinet. So we've got an 8 battery cabinet that's 40 kilowatt hours, a 12 battery cabinet that's 60 kilowatt hours, and we've got a 15 battery cabinet that you can do up to 15 modules all in series, or you can do 2 groups of 7 in parallel. So depending on what inverter you might be using, especially when we look at Solarc's commercial offerings, right? They've got a 30K and a 60K. The voltage input ranges on both of those units is actually a little bit different. So the 30K has a 500 volt input limit, meaning we can't connect any more than 8 modules in series. So if somebody needs more than 40 kilowatt hours, you can do more than 8 batteries. You've just got to create another stack. The 60K Solarc, on the other hand, has a higher voltage input of 700 volts. So we can do up to 12 in series on the 60K without any issues. And both of these inverters, I'll add as well, have 2 battery inputs. So the installation or the configuration, when you stick to what I say like a 1-to-1 or a 2-to-1 ratio, it's super, super easy. The packing list for the high voltage batteries comes with everything you need to connect not just the batteries together in the cabinet, but to connect that cabinet to the inverter. So you can see here with the 30K, we've got 2 stacks, so 80 kilowatt hours total. Each one of these is feeding into to a separate independent input on the inverter. So these actually aren't in parallel. The inverter treats these as separate batteries. Now, any input you have, Jock, feel free, but from what I've seen in the field, a lot of times the inverter does a pretty good job of keeping the 2 battery cabinets at the same level, but they are independent. And then you can kind of look at, these 2 examples in where's your bottleneck, like where are you limited, right? So this being a 40 kilowatt hour stack, it's only going to give you 20 kilowatts of output, right? So you're not satisfying the full 30 kW from the inverter. So in this case, the battery is the limiting factor. This other example, this should be 80 kilowatt hours, but now you've got 40 kilowatts, 20 from each cabinet, and the inverter only needs to take 30. So in that case, we can say the inverter is limiting, or in other words, the batteries can supply more than what the inverter can take. That same concept holds true for the 60K. The only difference is usually we're going to use the 12 battery cabinet instead of the 8, so we can get that voltage up a little bit higher. And then of course you can do more than just 2 cabinets, right? With both 30K and 60K. This example is 60K specific. When we get past that, like I said, 1-to-1 or 2-to-1 ratio, we need a couple accessories. Now we've run out of battery inputs on the inverter. We need to bring all the batteries to a combiner box and actually connect them in parallel. And then usually you have just a single communication cable from the inverter to again, this is our hub accessory, which is just an inexpensive communications management device. So all the batteries are communicating with the hub, and then it's the hub that's communicating with the inverter. Now, you can look at this group over here and call it a cluster, if you will, and you can basically have up to 6 of these cabinets in one cluster on a single inverter. Now, Solar, you can do 10, yes, 60K inverters in parallel in a single system. So imagine this cluster duplicated times 10 inverters, right? The scalability on the high voltage side is way, 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 way higher than anything low voltage we do. Low voltage, we top out at like 0.5 megawatt hour. High voltage, we can easily go, you know, close to 4 megawatt hours and even more in some cases. Because again, you can have 6 60 kilowatt hour cabinets, so 360 kilowatt hours per inverter times 10. And that's how you achieve these larger ESS products. But the high voltage battery has been out for at least a year, maybe 2 years now. We've got a lot of installs in the field. This is one in Hawaii that I've been working on. Another one in Mexico with Solar. This one I like to show off because it is the most, like, this is the definition of off-grid for me. This is a system, 0.5 megawatt hour system powering a off-grid eco resort in the country of Suriname, which is in South America. Like 90 to 95% of this country is dense, unpopulated Amazon jungle. You can only get to this site by plane or boat. They've been running the resort off of a generator for 20 or 30 years. They just recently upgraded to Pytes batteries plus Solar. And yeah, that system is up and running, and really just an example of, you know, what is possible with some of this equipment. This concept of improvement, product evolution, we've already released our 2nd generation high voltage battery. This is our HV48100se. And just like we saw from the V5 to V10 transition, this is a bigger and better product with more features, safety features, and not higher output, but just, yeah, lots of improvements. The cabinet is outdoor rated. It's IP55, I think. It has a 15 module capacity, which is just shy of 80 kilowatt hours. The cabinet has a 4-layer fire detection and suppression system. So it's got the fire suppression, hazardous gas detection, ventilation. It's got an explosion relief plate, kind of like that little vent we saw in the V10 at the top. And then the other thing is the modules have been completely redesigned. So it's maybe kind of hard to see, but the battery modules, they're still the same 5 kilowatt hours, 51.2 volt nominal batteries. They're connected in series, but the modules now have built-in heating pads, and they also have built-in ventilation fans. So we've got a heat pump on the outside of the cabinet that's going to do heating and cooling, and that blows the conditioned air towards the back of the cabinet, and those fans that are built into the modules individually pull that air through the battery to even further regulate temperature. And as I said, those modules have heating pads too. So a lot of the configuration we looked at with the indoor cabinet still applies to the outdoor cabinet. For a 30K inverter, right, we're going to do max is 8 batteries in series. So you could do 2 strings of 6 inside one cabinet. That gives you a 60 kilowatt hour solution with your 30 kilowatts of AC output. If you do a 60K, we want it to be just a little bit bigger, right? So now you're using 2 cabinets, 12 modules inside each, all connected in series. And that's going to give you, with 2 cabinets anyways, 120 kilowatt hours, and then satisfying the 60 kilowatts of the inverter. And yeah, these are just more examples with the outdoor cabinet. The PCS, or the inverter, mounts right on the side, as you can see right there. And then really for me, the only difference to point out here is when we look at a 30K versus a 60K inverter. Remember, because we've got 2 parallel strings within each battery cabinet, 1 battery cabinet with 2 parallel groups, we're already using both of the inputs on the inverter. So if we have a second cabinet with another 2 parallel groups, now we've run out of inverter inputs, and now we're using our combiner box. 60K is a little different, right? Because 60K, you can have 2 cabinets with 12 batteries in each, and then each cabinet feeds directly into one of the inputs on the inverter. So it's a little bit simpler, I think, but you can do kind of the same thing at the end of the day. Just a couple things on minimum sizing. This is for V10 specifically, but you can also do it with V5 and the other models. And kind of just looking at your inverter maximum AC output, how many batteries do we need to satisfy that? You also want to look at your inverter max charge rate, how many batteries do we need to accept that? And always round up, right? It's never a problem to have more. But what's interesting is some of these examples, right? Just really simple math. You can see we need 2 batteries to hit our 12 kilowatts for our Solar 15K with V10. But we need 3 batteries technically to accept that 275 amp charge rate. These are, I wouldn't say these are required quantities, but maybe more so recommended. Like if you did 3 V10 batteries on a 15K, I think you're good to go. You can use that inverter to its fullest potential without any worry. But I'm not saying that's a requirement, right? So if you're talking to a customer, I mean, I personally feel like customers are going to care a lot more about these top numbers than they are about these numbers, right? Usually that customer is going to place more importance on what can my inverter power, how many kilowatts of output am I getting. They're not really going to care so much about the charge rate. You know, if the system takes an extra hour or 2 to charge up fully, I don't really think too many people are going to be worried about that, but most people, especially for backup applications, they want that maximum AC output. AC coupling, DC coupling, right? If you're adding batteries to an existing grid tie system, you can do AC coupling. That just basically involves adding a battery inverter and connecting its AC output with that of your grid tie system. Most PV inverters nowadays can do power curtailment, and they work just fine with that. But I think that's a good option if your load consumption lines up with the solar day. So for example, an office, water pumping, desalination, like if you can satisfy all your loads with that solar output during the day, AC coupling is generally completely fine. What happens when we do AC coupling is the batteries, or I should say the solar converter would frequency shift, and you know, the PV inverter sees that and then knows to either slow down or speed up its charging. Well, sometimes that doesn't happen fast enough, and then you can have the situation where the total unlimited output of your PV array is dumped into the batteries. Maybe that's only happening for a brief moment, but again, because these batteries have a BMS, if you exceed what they're designed to accept, that BMS is going to trip, it's going to disconnect from the battery inverter. Now the solar doesn't have frequency to show to the PV inverter, so it's going to basically cause the whole system to crash. And this, again, if you're doing AC coupling, make sure you've got enough batteries. That would be my main advice. When to DC couple if you're off grid primarily, and you know, generally just better managed battery charging. You also got to think about your backup options. If it's grid connected, they want battery backup. You know, are we doing whole home versus critical loads? Do they even need backup, right? Some systems now, especially in California, where they implemented NEM 3, and now it doesn't make sense to sell your PV back during the day. Maybe they just want to buy and sell energy from the grid at different times and kind of do that energy arbitrage type scenario, but also want to think about your AC pass-through rating on the Solarc. I know the 15K is a 200 amp rated pass-through, so that's a really good option for whole home backup. And yeah, I'll skip through. I think most of this. Only other thing I'll leave with is updating firmware for the batteries. With all of our products, for me, it's if it ain't broke, don't fix it mentality. So I really stand behind that. I will say, like, if you're doing a new system and you're commissioning that system, go ahead and update the firmware on the batteries. It's a good time to do it. Or if you've got a site that's been running for like 6 months flawlessly, there's no problems at all, and all of a sudden the customer calls and they're like, hey, this shut down, I'm getting an alarm, the batteries have blinky red lights and they're beeping. For me, right, if we didn't change anything with inverter settings, if we didn't change anything installation-wise, firmware is usually going to be the first thing I'm looking at there. So we can update firmware 2 different ways. If you're on site, we've got a console cable accessory You can connect directly to the batteries with your computer. I can show that to everybody today. If you're off-site, all of our products have Wi-Fi monitoring capabilities. Some of them you need an accessory, and other times it's built in, but those are the two, kind of the two methods.
Through SolarMod you can do remote control and firmware upgrades through SolarMod?
Yes, yes you can. Right now, and I don't think I included much about that. So our app for Pytes monitoring, it's called Solar Man. And it's Solar Man. Yeah, it's the same app for our low voltage and our high voltage batteries. So we can do updates remotely, but at the moment they have to be pushed by our team. So all you have to do is let us know. I think we need the serial number from the Wi-Fi stick, and then you just need to confirm that the Wi-Fi dongle is connected to internet. And then the third thing, which is really important, is you want to make sure the batteries are in an idle state. So we don't want the batteries actively charging or discharging, because when we do these updates, and it's the same for on-site updates with the laptop, the updates reset the BMS and the battery itself resets. So we want the batteries to be in an idle state, meaning you know, disconnect the inverter or put your system in AC bypass mode, let the Jenny cover the loads, and make sure the batteries are just in standby.